Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Imagine a healthcare AI startup. A dev pushes a debugging snippet to GitHub, just one connection string. Hours later, an automated scraper finds it. For days, an attacker pounds the speech-to-text endpoint, exfiltrating patient recordings. The security team only notices when the monthly cloud bill spikes by tens of thousands of dollars. The root cause? A shared key with no identity, no expiry, no audit trail. If you're still resetting passwords in Tier 1 support, you're not just underpaid. You're one mistake away from this disaster. This video is your blueprint out. By the end of this video, you'll walk away with 3 concrete skills. First, you'll eliminate shared keys from any Azure AI resource using managed identities, an automatically rotated identity with no passwords, and role-based access control, or RBAC, which grants exactly the permissions your app needs. Second, you'll wire up diagnostic logging so you catch abuse before it becomes a 5-figure bill. And third, you'll see the 12-month career roadmap from help desk to security engineer with portfolio projects you can start tonight. Help desk roles often hit a ceiling early, while security engineers who can architect zero-trust identity systems command a substantial premium. The SC300 Microsoft Identity and Access Administrator certification validates exactly the skills that bridge that gap. The market isn't asking for more certs. It's paying engineers who can build identity-first systems from day one, often commanding significantly higher compensation than help desk averages. Here's what gets you there. Build practical skills with Microsoft Entra ID Identity Governance, earn the SC300 certification to prove them, and build a lab portfolio that demonstrates secure-by-design architectures. Those 3 moves stack the odds in your favor. This shift in thinking can dramatically grow your earning potential. You're moving from reactive firefighting to proactive defense. On the left, the help desk agent resets passwords as tickets roll in. On the right, the security engineer analyzes SIEM, security information and event management, alerts and designs identity-first architectures so no breach ticket ever fires. That's secure by design. You don't wait for the alarm, you architect the silence. Pause for a moment. If you've absorbed the last 3 scenes, answer this. What is the core difference between a Tier 1 support mindset and a security engineer mindset? Lock it in before we move to the gritty details of identity breaches. During a late-night debugging session, a developer copied the full connection string into a public Git repository and forgot to delete it. Within hours, an automated secret scanner, or an attacker's bot, found the key. For several days, the endpoint was hammered, exfiltrating sensitive data. The Security Operations Center only noticed when the monthly bill exploded. The real sting? Shared keys alone give you no built-in identity attribution. You can't tell which developer's key was leaked without piecing together logs from the IP source and the service side. In shared key authentication, the app stores a static secret and sends it with each request. While keys can have scoping and expiration policies, they still skip identity context. If leaked, an attacker can use them from anywhere. It's the simplest auth but also the riskiest. The move to identity-based access is the first step in zero trust. These two breaches are the same flaw in different clothes. On one side, an SSRF attack, server-side request forgery, lifts over-permissioned credentials from cloud metadata, leading to a massive data leak. On the other, a leaked shared key with broad permissions lets an attacker run up a huge bill for days. Both are long-lived credentials stored where they shouldn't be, with too much power. The pattern kills, not the platform. Let's lock in the key lessons. Managed identities eliminate shared secrets by giving your service an automatically rotated credential. No passwords to leak. Shared keys, on the other hand, hand an attacker the kingdom. Before we move on, test your grasp of the blast radius. Now, the secure flow. The container calls the cloud metadata service and gets back a short-lived token scoped to the AI service. It sends that token to the endpoint. The identity system validates the token and checks whether the identity has the correct data plane role. If yes, request proceeds. No shared key anywhere. Tokens aren't just for web apps. Any compute resource with a managed identity can authenticate without hard-coding credentials in environment variables, so no keys to leak. With just a few lines, default Azure credential automatically finds the identity. That tiny snippet is the entire authentication layer. No passwords, no rotation scripts, no keys to leak. Before you can design security for a production system, you need to live it in your own lab. The next 4 weeks aren't about reading. They're about wiring your fingers to the controls. First, ditch the portal for every cognitive services operation. CLI commands become your native language. Second, crack open Wireshark and watch the actual OAuth 2 token request. That's the industry standard authorization framework. Leave your container. Seeing the bytes makes the theory sink in permanently. Third, connect all the pieces in a free tier environment. A text analytics resource with local auth disabled, a container identity scoped to user, and diagnostic logs flowing. That trio is the foundation of every portfolio project that gets you hired. And here's the re-hook you need. Misconfigured identities are widely considered one of the most serious cloud security risks. But what you're about to build directly addresses that. This sequence is a critical security hardening step. Use your cloud provider's CLI to disable shared key authentication. Note that after disabling, any existing keys might still be valid for a short time as the setting propagates through the service. They won't be instantly dead. Eventually, once the change takes effect, the keys become invalid while the account itself remains. Verify the disablement setting is enabled, then you can test with the old key. It should eventually return a 401 access denied. If the earlier scenario had run these lines, a leaked connection string would become useless after the propagation delay. Most people rushing through a lab make one fatal mistake. They grant an application identity more permissions than needed, undermining the whole zero-trust design. Pause and test yourself. What permission level should you never give to a workload identity for an AI service? One misconfiguration can hand your application full service control. When assigning the identity, deliberately choose a role that only allows inference calls, never one that permits key management or resource deletion. Check your cloud provider's docs for the exact role name and the command to use. After the assignment, list the role assignments at the resource scope to double-check. This 10-second habit prevents a disaster. Test yourself now. What are the two critical technical steps that move you from key-based to identity-based access on a cloud AI service? Pause and recall, then I'll reveal the answers. The third leg of the stool is auditability. Without diagnostic logging on your AI service's data plane, you can't answer who called my AI service and why did it cost so much. Enable logging that captures operation names and caller identity, and optionally request JOC response payloads if your provider supports it. Route these logs to a centralized log workspace with a retention period that fits your compliance needs. Every inference call now carries the managed identity's fingerprint. If an attacker somehow obtains a token, you'll see the unauthorized requests in your query results within minutes, not days. Now you shift from reacting to tickets into operating a mini SOC. Open the Log Analytics dashboard for Contoso Healthcare. Run a query that counts the AI service's calls per hour, and look for a spike beyond your normal baseline. Once you identify a suspicious pattern, say a 10-fold increase from a typical few hundred calls to thousands per hour, you create a new alert rule conditioned on that query, wired to email you. The moment an attacker or even a runaway script abuses the AI service, you'll know before the bill climbs. This is exactly the monitoring pattern that catches anomalies in hours, not days. Replace every strip of key-based code with these patterns. Default Azure credential tries multiple authentication methods automatically. For example, managed identity when running in Azure, environment variables in development. So you don't have to worry about token management. You create the text analytics client with the endpoint and the credential object, and the SDK handles token renewal behind the scenes. The response comes back exactly the same, but now every call is tied to the workload identity you scoped. You can audit it, alert on it, and prove least privilege. From here, you'd wrap this into a function that also logs success or failure metrics to your Log Analytics workspace, turning your application into a self-monitoring component of the security architecture. That's the leap from help desk to security engineer. Time to lock in the diagnostics deep dive. Now answer, what kinds of logs give you per request attribution and content visibility? And how do you group API calls into hourly buckets to spot a sudden spike? Pause and test yourself. Picture a typical scenario. Shared keys stored in Kubernetes. Config maps potentially giving broad access, and rotation might require a full redeploy. One sprint later, after disabling local authentication and attaching a workload identity with the least privileged data plane role, the attack surface shrinks dramatically. Every inference call is now attributable to a specific service account, and the blast radius of a leaked credential drops to 0. The before and after are stark. Anyone with a key becomes only authorized workloads, fully audited. Here's the shift from surface-level IAM to identity-first engineering. A general cloud engineer often deals with shared secrets and basic role assignments, relying on static credentials that can become a security risk. An identity specialist, on the other hand, eliminates shared keys, uses managed identities, and scopes least privilege across every resource. The career impact is substantial. Identity-focused roles typically command a premium, and the shift from help desk to identity engineering can bring significant salary increases. Certifications like the Microsoft SC300 validate identity and access management skills, which are foundational to these patterns. To start, build a lab project where you replace API keys with managed identities in a cloud function. Then document it on GitHub. That's a portfolio piece recruiters look for. This is how you move beyond help desk tasks into designing secure, automated identity systems. Certs get your foot in the door. A public portfolio kicks the door open. Put a GitHub repo together with 3 pieces: a deployment script that bakes security in from the start, a README that walks through the threat model and how to verify the identity flow, and screenshots of your log analytics dashboards proving you can attribute every request to a specific managed identity. Recruiters for engineering roles look for proof of execution, not a bullet list of courses. This portfolio piece does more for you than any certification listing. 3 quick moves that change the jobs you get pinged for. First, your headline has to scream the role you want. Recruiters search for Azure AI Security Engineer and Managed Identity, not IT Support Specialist. Second, every resume bullet should read like an engineering outcome, not a ticket count. Instead of handled password resets, write designed identity-first access for 6 AI microservices, eliminating key rotation outages. Finally, drop a project section that links directly to the repository you just built. Those keywords are the difference between a generic rejection and a direct message from a hiring manager. The fastest path into an identity engineering role isn't applying through a generic job portal. It's an internal pivot. Volunteer for a security project in your current company, even if it's just auditing a few logs. Ask the cloud team if you can sit in on a PI planning session. Join cloud security Discord servers where engineers post real architectures and answer questions. Generic recruiters can't place specialists, but a peer referral from your network can. That's how you skip the resume pile and land an engineering interview. Let's apply what we've learned about making a career pivot. You're a Tier 1 help desk analyst aiming to move into security. What single portfolio project would most directly demonstrate identity-first zero trust skills to a hiring manager? Take a moment. The answer: build a lab where you configure privileged identity management and just-in-time access, then publish a walkthrough. This shows hands-on mastery of the exact controls security engineers implement daily. Managed identities simplify authentication, but real-world mistakes can still break your application. Here are the most common pitfalls and how to avoid them. Forgetting to assign a role gives you an access denied. Granting too much permission violates least privilege and increases blast radius. Token expiration without refresh leads to intermittent failures, and not all services support managed identities yet. Always check the docs. Keep this comparison handy when troubleshooting a 401 or 403 error. It'll save you hours of debugging shared key rotation. Let's lock in the 3 technical pillars and the career move they unlock. First, disable local authentication on your AI services. That means shared keys are no longer accepted, so even a leaked key gets rejected at the door. Second, attach a managed identity with a least privileged data plane role, like a read-only inference role, scoped to the exact resource. That's zero maintenance, least privilege access. Third, ship audit and request response logs to a centralized analytics workspace so you can see who called, what they asked, and whether abnormal behavior is happening. The career piece. You're now the person who can untie identity knots that cost banks hours of audit scope. That's the IAM engineer profile recruiters are chasing. Don't wait. Start documenting your build today. In Part 4, you'll design an anomaly detection and personalization pipeline that sits on top of this identity-hardened foundation. You'll know exactly who called, what they asked, and whether the response was biased. making your AI not just secure, but auditable and trusted. Hit subscribe so you don't miss the build. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.